Welcome to Silk Robotics, where we break down complex engineering into clean, visual stories. Today, we are tackling a common question in robotics and automation. What's the difference between a linear actuator and a linear motor? They both create motion in a straight line, but the way they work, and when you'd use each one, are worlds apart. Let's dive in. Let's start with the basics. A linear actuator is a device that converts rotary motion, usually from a motor, into straight-line motion. It often uses mechanical systems like lead screws, belts, or hydraulic pistons to do this. Simple, strong, and widely used. A linear motor, on the other hand, skips the mechanical conversion entirely. It produces direct linear motion using electromagnetic force, just like an unrolled rotary motor. So how do these systems actually work? A linear actuator typically starts with a rotary motor. That motor turns a lead screw, and the rotating screw moves a nut along its length. This nut pushes or pulls a shaft in a straight line, turning rotation into linear motion. It's a reliable method and often self-locking, meaning it can hold position even when powered off. Now imagine unrolling a traditional motor into a straight line. That's the idea behind a linear motor. The stator holds electromagnetic coils, and the moving part, called the forcer or slider, contains permanent magnets. When electricity flows through the coils, magnetic forces move the slider in a straight line, with incredible speed and precision. No gears, no screws, just direct contactless motion. Now let's compare them head to head. Linear actuators are generally slower, but they're simple, cheaper, and easier to set up. They're great for tasks where speed and precision aren't critical, like lifting, adjusting, or clamping. Linear motors, however, offer lightning-fast response, sub-millimeter accuracy, and ultra-smooth motion. They shine in high-performance environments, think robotics arms, semiconductor equipment, or maglev trains. In short, if you need power and simplicity, go with a linear actuator. If you need speed and accuracy, a linear motor is your best friend. So which one should you choose? Ask yourself, do I need high speed and responsiveness? Linear motor. Is cost or simplicity more important? Linear actuator. Does the system need to hold position without power? Actuator with self-locking. Can I handle complex setup and control systems? Then a linear motor might be worth it. Am I designing for harsh or outdoor environments? Consider waterproof or sealed actuators. The answer isn't always obvious, but with the right choice, your system will be smoother, faster, and more reliable. Let's talk about cost, because performance isn't the only thing that matters. A basic electric linear actuator might cost anywhere from $30 to $150, depending on stroke length, force, and build quality. You can even find budget models for DIY projects at under $20. In contrast, linear motors are more specialized and expensive. Entry-level models often start around $300 to $600, and industrial-grade ones can exceed $2,000, especially with integrated feedback systems and servo drives. But remember, you're not just paying for hardware. Linear motors often require dedicated motion controllers, position sensors, and clean operating environments, which add to the overall system cost. That's a wrap on linear actuators versus linear motors. If you found this helpful, hit like, subscribe to Silk Robotics, and leave a comment below. What would you like us to break down next? Stay sharp, stay curious, and keep building the future, one smart system at a time.